Now I want to talk about graphing functions. And I made the mention in the first video in the sequence that I almost want to call graphing functions super evaluating. Super evaluating. Now, what do I mean when I say that? I sort of feel like when you see this function, you guys have been trained, oh, that means y equals 3 minus 1 half x. That means y is negative 1 half x plus 3. And that means the graph is up 3, and from there, down 1 over 2, down 1 over 2. Yay, I drew the line. Here's the graph. And I feel like you guys see functions and graphs as like different things. Like a function has like letters and an f of x and stuff. And a graph has, like grids and a line. And you're like, yay, but they're totally different things. But they're not. Like, the thing to me is that these two things are exactly the same as one another. This is the function representation, and this is the graphical representation. And the reason that I call graphing a function super evaluating is that this graph effectively evaluates this function for tons and tons and tons of values. Right? When you look at this graph, what does this point right here mean? To me, this point means that if you plug in 2, you get out. Whoops, I know how to spell out. You get out 2. That point right there means that f of 2 equals 2. Right? What does this point right here mean? Well, it means that when you plug in 4, you get out 1. It means that f of 4 equals 1. Right? Similarly, this point over here, like, what does that point there mean? I mean, like, pause the video, think about it. And if you don't need to pause it, that's fine. But what does that point mean? That point effectively means that when I plug in 6, I get back 0. Right? I mean, now let me see if I can find another color. This point up here means that when I plug in negative 2, what do I get back? It means I get back the value 4. Like, for those of you that are not, like, super big fans of math, you don't like doing arithmetic and stuff, you should love graphs. Because if you had a picture of a graph, you actually wouldn't have to plug numbers into this. You could just look at it and say, oh yeah, when I plug in 1, I get back, I don't know, like 2.5, like 2.5. This graph is effectively showing you billions and billions and billions, infinitely many points. It's showing you what all of the inputs and the outputs are. And that's awesome. And I don't know that you guys have seen functions in that way before, but I want you to understand that any point that lies on a function tells you about the input and output of the function. And anytime somebody gives you an input and an output of a function, it means that you know about a point that's on that function. I want you guys to start seeing graphs and functions as simply different representations of the same mathematical object. So let's take that idea and go on and do some practice with it. So in this example, I want you to consider the function y equals h of x given below. And you may be looking at this going like, man, this is the ugliest function ever. And some of you may be going, no, this can't be a function. Like, if this was a function, what is its h of x equals? And the answer is it would be a terribly ugly piecewise function. It would be a piecewise function that had 1, 2, 3, 4, 5 pieces. And if you wanted to plug things into it, it would be a mess. In some sense, this function drawn this way is the best way to deal with it. Right? What I'm going to ask you to do now is to evaluate the function for these 6 values over here. Right? So I'll do the first one for you. What is h of 2? In other words, when you plug in 2, what do you get back? Well, when I plug in 2, I get back a value of negative 2. Like, the point here is 2 comma negative 2. That means h of 2 is negative 2. Right? Similarly, what is h of negative 3? Right? H of negative 3 means, well, when I plug in negative 3, I go down to the function right here. That seems to be negative 1.5. There you go. The y value associated with this, the output value, is, this y value right here of negative 1.5. I believe you guys should be able to go through and do the other 4 of these now. So go ahead and come up with your answers and what you believe that they are, and then we'll check answers together. Alright, so what's h of negative 1? When I go back to negative 1, there is not a point here, and there's not a point. When you have a hole in a function, it effectively means, by the way, there's no point here. So at negative 1, there doesn't seem to be a point anywhere. So that means that this function for this value is actually undefined. and at the beginning there I started to write equals, the function is effectively not equal to anything. The function does not have a definition. It is undefined. Right? Similarly, what is h of negative 6? When I try to go back to negative 6, there's no value of the function over there. So this one is also undefined. Now some of you may have said negative 3 there, and if you said negative 3, I'd say kind of, right? If there had been an arrow here, then I would agree. This means this is going back in a straight line sort of forever, so we'd expect it to be negative 3. But since there was just a point there, that sort of means that the function stops here, and we don't know what, rather negative 6 is undefined. Right? So the last two should be somewhat easier values. H of 3, well, when I go over to 3 on the function, my point is up here at a y value of 2, so h of 3 is 2. And then the last one, h of 4, you may have had trouble with this one. H of 4 is this y value up here. Now what is it exactly? I'm not sure what it is exactly. If you said 3.7 or 3.8 or maybe 3.6, 3.72, those all sound good to me. As long as you had in mind the concept of I am going over to an x value of 4 and then moving up to this y value, and you wrote down what you felt that y value was, I'm happy. Okay, so this has just been a brief intro to what a graph of a function is and how we use those things to evaluate functions and understand functions.